When dealing with underground gas lines and exterior lighting poles, maintaining proper clearance is crucial for safety and code compliance. This ensures that any potential hazards are mitigated and that both the gas lines and electrical systems operate safely and reliably. The primary focus is on the minimum clearance required between these two utilities, especially when the lighting poles have an opening near ground level for electrical connections. To address this question comprehensively, several aspects need to be considered, including the relevant codes, potential hazards, and best practices for installation. Firstly, it's important to understand the potential hazards associated with the proximity of underground gas lines and electrical systems. Gas lines, by their nature, carry flammable substances. Any leakage from these lines poses a significant fire or explosion risk. Electrical systems, particularly those with connections near ground level, can be susceptible to moisture ingress, corrosion, and accidental damage. These factors can lead to electrical faults, such as short circuits or ground faults, which in turn can ignite any nearby gas leaks. Secondly, the relevant codes provide specific guidelines for maintaining safe distances between underground gas lines and electrical installations. While the exact code may vary depending on the jurisdiction, the underlying principles remain consistent. The aim is to prevent any interaction or interference that could compromise the safety of either system. In the United States, the National Electrical Code, or NEC, is a widely adopted standard for electrical installations. It provides detailed requirements for various aspects of electrical work, including underground installations. Thirdly, the NEC addresses underground wiring in Article 300.5. While this section doesn't explicitly call out gas lines, it gives requirements for minimum cover depths of underground cables and raceways. It's worth noting that the NEC does not generally govern gas piping, but focuses more on the electrical systems. Therefore, one must look to other codes, such as those adopted by local municipalities or gas companies, for regulations concerning gas line installations. Fourthly, gas line installation is typically governed by local and state codes, as well as standards set by the gas companies themselves. These regulations often specify minimum distances between gas lines and other underground utilities, including electrical conduits and equipment. It's crucial to consult these local codes and standards to ensure compliance. The minimum clearance requirements may vary based on factors such as the type of gas line, the operating pressure, and the soil conditions. Fifthly, one must consider the specific design of the lighting poles. If the lighting poles have an opening near ground level for electrical connections, this introduces an additional risk. Moisture, debris, or even small animals can enter these openings, potentially causing electrical faults. Therefore, it's essential to ensure that the lighting pole is properly sealed and protected against environmental factors. Additionally, the electrical connections should be made in a way that minimizes the risk of accidental contact or damage. Sixthly, the depth of the underground gas line and the electrical wiring also plays a crucial role in determining the required clearance. Generally, deeper installations provide greater protection against accidental damage. The NEC specifies minimum burial depths for different types of electrical cables and raceways, depending on factors such as voltage level and whether the area is subject to vehicular traffic. Similarly, gas codes often specify minimum burial depths for gas lines to protect them from damage. Seventhly, when installing underground gas lines and electrical systems in close proximity, it's advisable to use physical barriers to provide additional protection. These barriers can be in the form of concrete slabs, warning tapes, or other protective materials. The purpose of these barriers is to prevent accidental contact between the gas line and the electrical system during excavation or maintenance work. Eighthly, proper grounding and bonding of the electrical system are also essential for safety. Grounding provides a low impedance path for fault currents, which helps to trip circuit breakers or fuses and prevent electrical shocks. Bonding ensures that all metallic parts of the electrical system are at the same potential, reducing the risk of electrical hazards. The NEC provides detailed requirements for grounding and bonding in Article 250. Ninthly, regular inspections and maintenance are crucial for ensuring the continued safety of underground gas lines and electrical systems. Gas lines should be inspected periodically for leaks, corrosion, and other signs of damage. Electrical systems should be inspected for loose connections, damaged wiring, and other potential hazards. Any issues that are identified during these inspections should be promptly addressed. 10thly, documentation is also very important. Keeping detailed records of the installation, including the location of gas lines and electrical systems, the depth of burial, and the materials used, can be invaluable for future maintenance and repair work. This documentation should be readily accessible to anyone who may need to work on the systems. 11thly, consider the voltage levels of the electrical system. Higher voltage systems generally require greater clearances due to the increased risk of arcing and electrical hazards. The NEC provides specific clearance requirements for different voltage levels in various applications. It is important to adhere to these requirements to ensure safety. 12thly, soil conditions can also influence the required clearance. Corrosive soils can accelerate the deterioration of both gas lines and electrical cables, increasing the risk of leaks and electrical faults. In such cases, it may be necessary to provide additional protection, such as corrosion-resistant coatings or increased clearance. 13thly, emergency procedures should be in place in case of a gas leak or electrical fault. These procedures should include instructions for shutting off the gas supply, energizing the electrical system, and contacting the appropriate authorities. All personnel who may be working near underground gas lines and electrical systems should be trained on these emergency procedures. 14thly, the use of ground fault circuit interrupters, or GFCIs, can provide additional protection against electrical shocks in areas where there is a risk of moisture or accidental contact. GFCIs are designed to detect small ground faults and quickly de-energize the circuit, preventing serious injury or death. The NEC requires the use of GFCIs in many locations, including outdoor areas and areas where electrical equipment is likely to come into contact with water. 15thly, surge protection devices, or SPDs, can help protect electrical equipment from damage caused by voltage surges. Surges can be caused by lightning strikes, power outages, or other electrical disturbances. SPD divert the surge current away from the equipment, preventing damage. The NEC provides requirements for the installation of SPD in Article 280. 16thly, when working near underground gas lines and electrical systems, it's crucial to use safe excavation practices. This includes using hand tools or vacuum excavation techniques to avoid damaging the underground utilities. Before digging, it's essential to contact the local one-call center to locate any underground utilities in the area. 17thly, signage and marking can help prevent accidental damage to underground gas lines and electrical systems. Warning signs can be placed in areas where underground utilities are present, and marking tape can be buried above the utilities to alert excavators to their presence. The signage should be clear and easy to understand, and the marking tape should be durable and visible. 18thly, the coordination between different utilities is essential for ensuring the safe installation and operation of underground infrastructure. Utility companies should communicate with each other to coordinate their activities and avoid conflicts. This coordination should include sharing information about the location of underground utilities and developing procedures for working safely near each other's facilities. 19thly, the use of trenchless technologies, such as horizontal directional drilling, can minimize the disruption to the ground surface and reduce the risk of damage to underground utilities. These technologies allow utilities to be installed without the need for open trenches, reducing the potential for accidental contact. 20thly, proper backfilling and compaction are essential for ensuring the stability of underground utilities. The backfill material should be carefully selected to provide adequate support and protection for the utilities. The backfill should be compacted in layers to prevent settling and ensure that the utilities remain properly supported. 21stly, the use of cathodic protection can help prevent corrosion of underground gas lines. Cathodic protection involves applying a small electrical current to the gas line, which helps to prevent corrosion. This technique is particularly effective in corrosive soils. 22ndly, monitoring the condition of underground gas lines and electrical systems can help identify potential problems before they become serious. This monitoring can include regular inspections, pressure testing, and electrical testing. The data collected from these monitoring activities can be used to identify trends and predict potential failures. Thirdly, the use of remote sensing technologies, such as ground-penetrating radar, can help locate underground utilities without the need for excavation. These technologies can be used to create a map of the underground utilities, which can be used for planning and maintenance purposes. Fourthly, providing training and education to workers who may be working near underground gas lines and electrical systems is essential for preventing accidents. This training should cover the hazards associated with underground utilities, safe excavation practices, and emergency procedures. The training should be regularly updated to reflect changes in technology and regulations. Fifthly, the use of drones can facilitate inspection of difficult-to-reach areas such as power lines, gas lines on bridges, and remote installations. These can carry different sensors which can detect the presence of gas or electrical shorts or other potential risks. 26thly, regular reviews of safety procedures are also critical. This will help ensure compliance and that you are up to date on standards of care. 27thly, the opening for electrical connections near ground level on the lighting pole requires special attention. This area is particularly vulnerable to moisture and corrosion, which can lead to electrical faults. Therefore, it's essential to ensure that the opening is properly sealed and protected against environmental factors. Additionally, the electrical connection should be made in a way that minimizes the risk of accidental contact or damage. 28thly, the wiring within the pole should be appropriate for the environment. Using wet-rated wiring is important, as is making sure the pole is adequately grounded. Any splices and wiring should be done professionally and sealed so as to prevent moisture from getting in. Therefore, in summary, the clearance between underground gas lines and exterior lighting poles with electrical connections near ground level must adhere to local codes and gas company standards. Pay close attention to sealing electrical connections from the elements and ensure proper grounding. Regular inspection and maintenance are key,